So the last chapter is kind of a simple chapter. We've already covered it. Some of you that have CPS 161 are now going, yeah, we just covered it there as well. It was a different language, but it's the same kind of idea. And some of you in 162 are going, yeah, we used recursion with the left child and the right child, and we see a use for it, and it's all good. But I'm assuming there may be some of you that aren't taking any C++ classes. So we do, once again, cover it here. We looked at it problem wise. Now I want to look at it code wise. So if I asked you to knock the rust off and calculate f of 8, who can go through that and give me the answer to that burning question, f of 8? So you need 8 times 7 times 6 times 5 times 4 times 3 times. Holy cow, I made that a hard problem. Sometimes you pick up patterns really quick. I did some scribble and I got 383. Anybody else? Wait, I'm still going. So I knew as I was counting down, I basically went and said, oh, this is going to keep going down till 2. So I went and found 2, then plugged it back in. 2 times f of 2 gave me f of 3, which was 11, 23. So I sort of did it a different way. Did anybody else get 383? Anybody? Nobody? I guess I'm just going to move on. So the video is not, okay, Ryan got it. All right. So for most of you, you can now tell me if I look at this function, this line right here is called the what case? Okay. It's called the
Base
base
case.
case. Yeah, this is called the base case. This is called a recursive case. Now, in this example, well, I don't know why I spelled. In this example, we only have one base case. We only have one recursive case, but we could have multiple base. We could have multiple recursive. It all depends on what we want to do. So if I asked you to code this, again, it's going to be a function. Each time down here when the function returned, what type of value was being returned? So I found f of 2 and I returned it so that it could go up here. Looks like an int. So let's start looking at some code. Public static int. Now I know values being returned. I'm just going to call it x. I forgot to name my function. Sorry about that. What do you want to call this function? How about fun? Good, because we're all having fun right now. Fun. And I'm going to come inside of here. Somebody help me. I'll get the party started. If. Might as well take.
You test for the base case first?
Yeah, absolutely. If x is less than 3, what am I going to do? That means I got down to here and somehow or other this value got returned so that it can be used there. So I'm just going to go and have a nice simple return of x times x plus 1. Else, well, what am I returning now? Return. Somebody's gonna have to give me this one because you're wearing me out. I'm tired. Who was this?
2.
Yep, go ahead.
2 times fun of x plus 1.
I think
X
2.
yeah, x.
Yeah, 1 less and then plus 1. That's it. Nice, short, sweet, simple, and of course, fun. Some of the examples you looked at in the book, the code listings you typed in. Simple example of a recursive function where inside of here, line 13, I call the function again. So this is a function calling another function. And I keep going all the way down, sort of knocking out that base case. Code listing 15.3 you typed in. Recursion demo. Down at the bottom it says recursive message 5. And it gave me all of the output for that. Return of the Mac. That was using a class. 15.4 factorial demo. You know, how am I doing a factorial? If I want to use recursion and say, call a factorial subnumber, means I'm sending a number in. If it's 0, that's my base case. I have 1. Otherwise, I return that number times 1 less. So if I called factorial 4, I would come in here and go, oh, I'm going to return 4 times factorial 3. Factorial 3 is 3 times factorial 2. And I would keep repeating until I got all the way down to 0. It would return 1. just like we worked with, we just, by hand with the selected topics, we just keep working our way back, working our way back. We'd find a value for this, multiply it by 4, and it would return back to the main. Lots of different examples. Circles. You typed in code listing 15.6 and it kept calling and displaying a circle inside of a circle inside of a circle, and it kept getting smaller and smaller till it hit a certain base case. Yeah, typed in Fibonacci numbers. This one actually has 2 base cases. If n is 0, return 0. If n is 1, return 1. Otherwise, I had a recursive call. Kind of nice. From there, we could build all kind of recursive stuff. You know, instead of it being the sum of the previous 2, we could say it's 3 times the previous number minus 4 times the number before that, or something. Playing all around with it. A lot of you had CPS 161, so GCD demo was good. In fact, we were using the ever popular what method here. Starts with a U. Or excuse me, it starts with an E. Sounds like a U. What was this method called? Where if I divided them and it went evenly, then I returned Y, which was the divisor. Otherwise, I recursively called the smaller number, comma, modded the 2 numbers.
Euclidean method?
It was the Euclidean method, right? And some of you are in 161. That should still be fresh in your head. All right, so not doing anything else. Going to come back to this. I'm going to ask you to quickly write this program. See if f of 8 does in fact equal 383.